So let's talk about surrounding and boundary. Let's see surrounding. We were saying surrounding here, right? We were talking about surrounding here. So what does it mean? So anything outside the system is considered as surrounding. Let's say this is the system. If we say this is the system, anything outside this one is, we call it surrounding. So we have immediate surrounding refer to the portion of the surrounding that's affected by the process. If the surrounding which is closer to the system, it's obvious it's going to be affected by the system, so we call this immediate surrounding. And environment refers to the region beyond the immediate surrounding, whose properties are not affected by the process at any point. So if we say this system and if we say this is immediate surrounding, then beyond this we call environment, which is not affected by the properties or by the process at any point. So as you can see, this one, the system, we have hot potato, which is at 70 degrees Celsius. Let's say at this point is 25 degrees, which is environmental temperature. Let's say the environment is this one. So here we can have 65, 60 or 40 something. So we call this immediate surrounding because this is affected by the system. So we call this immediate surrounding. But outside of this, there is equal temperature, 25, which is environmental temperature. So this one is environment, which is not affected by the process at any point. Okay, so what does boundary mean? A surface that separates the system from its surrounding. So we say we have system, so a surface that separates the system from the surrounding, we call it boundary. The contact surface shared by both system and surrounding, or we can say the contact surface, this one, both shared by the system and the surrounding. Both shared by system and surrounding. Mathematically speaking, the boundary has zero thickness. Like, if we are talking about mathematically, we couldn't say it has this thickness, it has this thickness, but we say like it has zero thickness. It can neither contain any mass or nor occupy any volume in space. So if there is zero thickness, we can say it cannot contain any mass or occupy any volume in space. So as you can see, this one is the imaginary boundary. Real boundary is the imaginary boundary. Or you can take this one, right? So like I think you've got the difference between surrounding and boundary. Now let's see the difference between real and ideal gas. What's the difference between real and ideal gas? Ideal gas, PV over T is constant because it's ideally, we're talking ideally, that if we see in real gas, PV over T is not constant. It's obvious. And also here we consider negligible volume. We consider there is no volume, negligible volume, but here still there is non-zero volume. It's just our assumption. And also here we consider no intermolecular attraction, but here there is intermolecular attraction. So the difference between this ideal gas and real gas looks like this. Like we have here negligible volume, but we say there is no non-zero volume, no intermolecular interaction, but here intermolecular interaction. And the other thing is, at low temperature or high pressure, real gas behaves differently. But at standard temperature and pressure, real gas behaves similar to ideal gas. So if we manage to set the standard temperature and pressure, we can say real gas behaves similar to ideal gas, but at low temperature or high pressure, real gas behaves differently than the ideal gas. Other interesting topic is about matter. So the other interesting point is matter. So let's see what matter means. It occupies space, possesses mass, may exist as a solid, liquid, or gas, right? So we have two points that we have to consider. The first one is pure substance. The second one is mixture. So impure matter having a fixed chemical composition and distinct properties, we call this pure substance. But matter consisting of two or more pure substance, we call this mixture. So in pure substance, it could be in elemental form, or it could be element, or it could be compound. Element means fundamental substance cannot be separated into simpler substance by chemical methods. If we cannot manage to change them, this pure substance, we can say that we can take them as an element, which is an example of this gold. And compound substance composed of two or more elements, like two or more elements in fixed proportions. can be separated into simpler substance only by chemical methods. Like you can say, for example, sodium chloride. We can take as a compound but in pure substance. And if we're talking about mixture, we have homogeneous and heterogeneous mixture. Homogeneous mixture having a uniform composition and properties throughout, also called a solution. There's a homogeneous or having a uniform composition. You can take, for example, apple cider vinegar. But if we are talking heterogeneous mixture, there is non-uniform in the composition. That one is uniform, but here it's non-uniform. So most of the time we have sweet chili sauce. So like try to have in your mind matter, then there's pure substance and there's mixture. In pure substance there's element and there's compound, but in mixture there is heterogeneous and homogeneous mixture.